Okay, so up here at the top, we have a reminder, first of all, that multiplying, when we are multiplying, we want to multiply our coefficients and add our exponents. When we are factoring, we want to divide our coefficients and subtract our exponents. And then when we combine like terms, we add our coefficients together, we leave our exponents alone. So we are going to be factoring all of these polynomials. And then I have left a space on all of these for us also to check our answers by multiplying, because factoring and multiplying are always the opposites. So the first method of factoring we learned was greatest common factor. We use this if there is a common factor between all of the terms, and then we factor that out. When we factor, we divide our coefficients and subtract our exponents. So right here, out of 12x to the fourth, 16x cubed, and 8x, first thing I'm going to do is put an imaginary 1 right there on the 8x. I'm going to make that 8x to the first. Then I have to ask myself, what can I divide 12, 16, and 8 by? 4. So I can divide all of those things by 4. And then for our x's, we've got x to the fourth, x to the third, and x to the first. We can always take out however many the one with the least x's has. So I'm going to pull out an x to the first here. And then from there, I'm going to go ahead and divide that out. So 12 divided by 4 is 3. And I subtract my exponents. 4 minus 1 is 3. 3x to the third here. Negative 16 divided by 4 is negative 4. Subtract my exponents. 3 minus 1 is 2. And then 8 divided by 4 is 2. Subtract my exponents. 1 minus 1 is none left. Any questions about the factoring on that one? Right. And then what this box right below it is for is we are going to multiply out all of our answers to check them on this little review. So 4 times 3 is 12. And then I would add my exponents. 1 plus 3 is 4. So I've got 12x to the fourth. 4 times negative 4 is negative 16. I'm adding my exponents. 1 plus 2 is 3. And then 4 times 2 is 8. X to the first plus none, still x to the first. So I can then look and double check that what I had here and what I have here is the exact same. Okay, I'm going to go ahead and pause this video. All right, so in 5.6, we factored quadratics. This was part 1. In part 1, we had 3 terms. So 1, 2, 3 terms, no number in front of x squared, which is technically an imaginary 1. We're going to find 2 numbers that multiply together to be the last number and add together to be the middle number. So in this example that we have down for us together, I'm going to put an imaginary 1 right here. We're finding 2 numbers that multiply to negative 20, and they need to add together to be negative 1. Numbers that multiply together to be 20 are 1 and 20, 2 and 10, 3 doesn't work, and then 4 and 5. Since we need to multiply to be negative, we want to make one of those numbers negative. Since we want to add to be negative, we want to make the bigger one negative. So this 5, if we make it negative, 4 minus 5 is -1, or 4 plus -5. Okay, we're going to write that out in factored form. So it'll be x plus 4 times x minus 5. And that would be our solution. All right, any questions about the factoring? Okay, once again, we're going to multiply these out. We're going to put x and 4 over here on the left. So since it's binomial times a binomial, we're doing our 2 by 2 box. We're going to put x and -5 up here above. X times x is x squared. X times -5 is -5x. Four times x is 4x. And 4 times -5 is -20. Once we get things multiplied out in our boxes, we can also combine like terms. So this x squared stays by itself. My 4x and -5x combined together. 4 minus 5 is -1. And I still have my -20. Okay. Any questions about factoring or multiplying on these ones? Okay, we're going to give you guys 3 minutes to work on that one on your own, then get it multiplied back out too. If you need to go back and finish the first one, you can do that now too. Okay, grouping is kind of a split up version of what we did in 5.5 with greatest common factor. Grouping we use when we have 4 terms. We factor the greatest common factor out of the first 2 terms. We factor the greatest common factor out of the last 2 terms. And then what's left behind matches. We write our answer as those 2 things that are left behind that match, and then our greatest common factor plus our greatest common factor. So in this one, we're going to be looking at these first 2 terms. So out of 2x cubed and 6x squared, I can divide both those by 2. And then I can also pull an x squared out of each of them. So 2x squared. 2 divided by 2 is 1. X cubed, take away 2 of the x's, leaves behind 1x. So I've got 1x left. 6x squared divided by 2. The 6 divided by 2 leaves behind a 3. And then the x squared, divide out the x squared. Those x squareds are gone. They're completely factored out. Okay. Out of -3x and -9, I can divide both of those by a 3. Since this is -3x, since my third term is negative, I want to divide out a -3. So my GCF for my last 2 terms is going to be -3. -3x divided by -3 leaves behind just an x. -9 divided by -3 leaves behind a +3. When we are factoring by grouping, it is our goal that what is left behind, this and this, are the same, and they are. So that x plus 3 is my matching term. That's going to come out first. And then my other factors are going to be this 2x squared and this minus 3. 2x squared minus 3. Okay. Any questions about the factoring by grouping? Okay. So then on the left here, to multiply this back out, we're going to put x plus 3. So I've got x and positive 3. And then across the top here, I've got 2x squared and negative 3. From there, I can go ahead and multiply this out and put my imaginary 1 right here. So 2x squared times x squared, I add my exponents, so I get 2x cubed. Top right-hand corner, I've got x times negative 3, so that's negative 3x. Bottom left-hand corner, 3 times 2x squared is 6x squared. And then bottom right-hand corner, 3 times negative 3 is negative 9. From there, we can put all of our terms in order. Nothing can combine here because they all have different exponents. So I've got 2x cubed, 6x squared, negative 3x, and negative 9, which is the original problem I was trying to work on. All right, I'm going to give you guys 3 minutes to work on this problem. That may or may not be enough time, but I want to make sure we have enough time to get through these last 2 problems. So go ahead and just get started. If you don't get it multiplied out, that's fine for right now. You can do that part later. Okay, difference of squares. We have 2 terms that are both perfect squares. So 9x squared and 49. 9 is a perfect square. 9 is 3 times 3. X squared is x times x. So I'm going to write down right here a little 3x just to remind myself, because 3x times 3x is 9x squared. What is 49 the perfect square of? 7. 7 times 7 is 49. So those are essentially my A values and my B values there. The rule for difference of squares tells me if I've got these 2 perfect squares, so a perfect square minus a perfect square, difference means subtraction, then my answer can be ax plus b times ax minus b. So this is going to be 3x plus 7 times 3x minus 7. So we find the square roots of these guys, and then it's a plus version and a minus version. If I wanted to multiply this guy back out, I can put 3x plus 7 on the side, 3x with a negative 7 across the top. And then I can start multiplying from there. So 3 times 3 is 9. X times x is x squared. Three x times negative 7 is negative 21x. Seven times 3x is positive 21x. And then 7 times negative 7 is negative 49. These middle terms here, that 21x and that negative 21x, cancel out, which is why my answer is just going to be this 9x squared and this minus 49. All right, last problem we're doing together, 5.9. We're factoring quadratics. This was part 2. If you have understood everything up until here, please recognize that you don't give up on yourself if this one's still a struggle for you. Okay, this is the hardest thing we've done all year. We have 3 terms with a number in front of x squared. We need to find 2 numbers that multiply together to be a times c, which is our first term times our last term, and add together to be b. This should say like 5.6. Forgot to correct those section numbers. So first thing that we're going to do, my a value is 12. My b value is negative 4. And my c value is negative 5. We're going to multiply together a times c. A times c is negative 5 times 12. That is negative 60. We used that magic x to find 2 numbers that multiply together to be negative 60. They need to add together to be negative 4. We could list out all of our factors of 60 if we needed to. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Is that it? I think that's it. Okay, so I could write all those down if I wanted to. For the sake of time right now, I'm going to tell you that the ones of those that are 4 apart are 6 and 10. So I'm going to put a 6 here and a 10 here. And then in order to make them multiply to be negative and also add to be negative, I want to make the bigger one negative. So 6 and negative 10 are the numbers that multiply together to be negative 60, add together to be negative 4. Okay, we're going to take our original problem. I'm going to rewrite it right here. 12x squared minus 4x minus 5. That's just me rewriting the original. We are now splitting this negative 4x into 6x and negative 10x. This 12x squared stays the same. The minus 5 stays the same. From there, we factor like grouping. This should say like 5.8. This should actually say like 5.7. Completely wrong on my section numbers. Okay, so out of 12x squared and 6x, I can divide both of those by 6. And I can also pull out an x from each of them. So 12x squared divided by 6x is 2x. 6x divided by 6x is 1. Out of negative 10x and negative 5, I can divide both of those by a negative 5. So negative 10x divided by negative 5, lose mine 2x. And negative 5 divided by negative 5, lose mine to positive 1. Okay, these 2x plus 1's match. So they become my first term. And then the other part of my answer is this 6x and this negative 5. Okay. Now that I've got that factored out, just like with the rest of these, I can check it by multiplying. So I can put 2x and 1 here on the left, 6x and negative 5 up here on the top. 2 times 6 is 12. X times x is x squared. Top right-hand box would be 2x times negative 5, which is negative 10x. Bottom left hand, 1 times 6x is 6x. And then bottom right hand, 1 times negative 5 is negative 5. Combining like terms, I've got a 12x squared here. I've got a 6x and a negative 10x here. So those can combine together to be negative 4x. And I've got a minus 5 as well, which was what my original problem was.